Hi everyone, in this video we'll talk about the concept of probability sampling. Probability sampling, okay? So when we talk about the concept of inferential statistic is when we want to use sample to estimate our population. And then the way we do this is through sampling, right? So we're going to collect a bunch of sample and then do the estimation. So we're going to do sampling to estimate population parameters. Okay? And in this case, we're interested in the population mean. So we are interested in population mean, just our mu. And what's the goal here? So when you do sampling, your goal is always you want to be able to collect a set of sample that's representative of the population. So the goal is sample can be representative of the population. And which means that the way you sample can make a huge difference. And the way you sample can result in a set of samples that's representative or a set of samples that are not representative of the population. And you always want the samples that are representative of the population. And then there are two general types of ways to sample. So there are two general types. Okay, so two types. First type is what we call probability sampling. Probability sampling. And then the second type is non-probability sampling. Non-probability sampling. And in this video, we'll be focusing on the first type, probability sampling. And yeah, so we're focused on this one, and then next video we'll talk about the second type. Okay, I'm gonna keep this title here. Okay, so for probability sampling, there are 4 features, right? So you need to satisfy these four features to have a probability sampling approach. So there are 4 features. So under probability sampling, there are 4 features. The first one is your sample is picked in a well-defined way. And this well-defined way, it has to be before your sampling. So you're not changing as you do the sampling. So be before sampling. Okay. And then second feature, the sample is random. So the sample is random. Okay. And then the third one is no personal choice are made by you or by the person who do the sampling, or here let me use the word the experimenter. Okay. So personal choices are not involved in how you do the sampling here. And then the fourth one is the probability of any individual or any subject being selected, it's calculable. Okay, which means that you know the probability of each single object or each single individual being selected. You know the probability, or you're able to calculate the probability. Okay, so if the way you sample satisfy these 4 features, then you're doing a probability sampling method. Okay, and then under probability sampling, there are 4 types of probability samples. Okay, and there are 4 types. And types of probability samples. Okay, the first one is the simple random sample. Okay, simple random sample. The second one is our systematic sample. Okay, and then third one is our stratified sample. And the fourth one is our cluster sample. Okay, and then we'll talk about each single one of them. Okay, 4 types. Now let's start with the first one, simple random sample. Okay, first one, simple random sample. Okay, this one is always the most desirable one. Okay, let me say this one is the most desirable one. And in order for you to have a simple random sample, you have to satisfy the following 2 features. So you have these 2 features. Okay. The first one, let me use. Okay. The first one is unbiased. Unbiased. What do you mean to be unbiased? Unbiased means every person. So if you're doing an experiment with people, each person has likely chance being selected, right? So the probability of every single one in the population, it's equally likely to be selected, right? So if you're interested in getting the Cal State Los Angeles students average GPA, then in order for you to have this unbiasedness, then you need to have the probability of each single student being selected to be the same, right? So they have equally likely chance being selected. So this one's biased. We move to this side. And second one is independent. Okay, independent means that one person selected doesn't affect the probability of other being selected, right? So this concept is the same as the concept we talked about before. It's just that the probability of one object or one person selected does not affect the one previous and the one after, right? So each single person draw from the sample is independent from each other. So if you have these two features, so if two features, let's say, are satisfied, and you have the simple random sample, okay, then you have the simple random sample. Okay, next. When people do simple random sampling, they have two methods to do it. One is what we call with replacement. Another way is called what we call without replacement, which means that you take a sample out, or you take one object out, whether you're gonna put this object back for the next sampling or not. So let me just write it out. For the simple random sample, we have two methods. Two methods. Okay. The first one is with replacement, which means that you sample one object out, you pick one object, and then you're going to put it back for the next selection, sample selection. Where the second method is without replacement, right? Without replacement just means that once the object is selected out of the population, it's not going to go back to the population for a next sampling. Okay. Sounds good. Okay, so next, let me just quickly give you an example of a simple random sample. Example. Okay. So you want to estimate. So the goal is to estimate Cal State, Los Angeles students' average GPA. Okay, so we want to do this. We want to find the Cal State students' average GPA, or the mean GPA mean, and then the population here is our Cal State LA students. And then the way we do this, is we're going to randomly selected by computer of 300 Cal State LA students, right? We're randomly using computer to pick out 300 students, and then we're going to calculate the mean of these 300 students. I'm going to calculate the sample mean of these 300 students. Okay, and then we're going to get our X bar, right? So we have our sample mean, X bar here. Okay, and then we're going to use this X bar to estimate our population mean, which is the Cal State students' average GPA. Okay, so this is what we're going to do here. And as in this example, since we're randomly selected 300 students and we're using computer, and then each single one are likely to be independent, in this case, the method here is satisfied the two features that we discussed. So this is a random. This is a simple random sample. Okay, so let me write out what I said, the conclusion, right? So since this approach satisfies this approach satisfies the two features that we discussed. This is a simple random sample. Okay, so again, you will need random and independent, these two features, for you to have a simple random sample. And simple random sample is always the most desirable one, because just you'll be able to represent the population very well. Okay. Next, the second type of probability sampling is our systematic sample. So F2 is the systematic sample. Okay, so what does it mean for you to have a systematic sample? It just means that you have a regular pattern of how you select your sample. So you have a regular predetermined, regular pattern to select your sample. Okay, let me give you an example. Okay, so we're interested in the height of students in this class. Okay, and then the way we do this, the pattern, the sample pattern, we're gonna get the height of every second student enter the classroom. Okay, so every second student or every other student enter this classroom will get their height, and we'll take the average, and then we're going to use the sample mean, sample average to estimate the population height. Okay, so yes, so let me just finish this and say take sample x bar for estimation. Okay, so this is how we're going to do it, right? We have a regular pattern, and then we're going to follow this pattern to get our sample. But there's a problem with this method. Let's talk about some of this method. Potential problem. Okay, so in this case, some objects are impossible to choose. There are just samples that you can never get. Or no, there are objects you'll never be able to get into a sample, right? So in this case, say the first, the third, students, they will never be selected. Never being selected. Okay, so this is a potential problem. There are objects in the population that you just can never get into a sample if you just keep following this pattern here. Okay, good. This is our systematic sample. Next, we're going to talk about third type, which is stratified sample. Third type. Stratified sample. Okay, So stratified sample, the way we do this, we're gonna divide the population into similar groups, and then we're gonna sample from each group. Divide our population into similar groups. And for the groups, we're going to call them strata. Okay, we're going to call them strata. And then we're going to take sample from each strata. Okay, then we're going to take sample from each strata. Okay. So basically, we have a population. We're gonna separate them or divide them into groups, similar groups, and then from each group, we're gonna pick our sample. Okay. Let me give you an example. Okay, example. So in this example, we're interested in California's residents view on e-cigarette. E-cigarettes. Okay, so we're interested in the residents view on e-cigarettes, but we're concerning that in California, there will be a lot more Democrats than Republicans in the state, right? So are we able to be fair by taking the same amount of Republicans and same amount of Democrats? So the way we do this is by using the stratified sample. We're gonna divide the whole California population into Democrats and Republicans. Okay, and then the way we do this, or the reason, is to prevent too many Democrats in the sample, right? So if you do the simple random sample method, and if there's a lot more Democrats in your population, then you're likely to have more Democrats in your sample. Okay, but now we're gonna separate them into two groups, and then from each group, we're gonna pick out 50 Democrats, and we're gonna pick out 50 Republicans. Okay, so now we're gonna have even numbers of Democrats and Republicans in the sample. We have even numbers of Democrats and Republicans. Okay. Okay, so this is good, right? So we don't have too many Democrats and too many Republicans. It's fair, right, in our sample. So the next, we're just gonna take the sample mean, and then to estimate the population's view on these secrets. Okay, so we're gonna do the sample mean here. Okay, good. However, once we're done with the sample mean step, we'll have to make adjustments, right? Because in our population, we in fact have more Democrats than Republicans. So once we collected the sample and then get the sample mean, and we want to use the sample mean to estimate the population, the whole population view, we need to make adjustments. So next step, or the final step, is we need to make adjustments for more Democrats in California, right? The way we do this is by putting more weight on your sample mean, or on Democrats' sample mean. Okay, so we're going to put more weight on Democrats because we have more Democrats in our population. Okay, we need to make adjustments. Okay, the part is important. Good. Next is our last type, fourth type, cluster sample. It's our cluster sample. Okay, in cluster sample, and cluster sample, it's a type of stratified sample. So it's in fact a type of stratified sample, right? So it's one type of stratified sample, but you're gonna divide them in finite groups. So, but in finite groups, and usually this method is applied to geographic area samples, right? So it's more likely that it's usually that it's applied to geographic area sample. And let me give you an example here. Okay, so we are again interested in California residents' view on e-cigarettes. But now the way we do this, we're going to randomly select 10 counties in California. Okay, so we're gonna divide California into counties, and then we're gonna randomly pick 10 of them, and then in each county, we're gonna choose county randomly choose 10 zip codes. Okay, so we're gonna in counties we're gonna divide them again into 10 into zip codes, and we're gonna pick 10 of them, and then in each zip code we're gonna pick 10 random blocks, and then in each block we'll randomly pick out 2 random people. Okay, and in this case, with this way we're able to randomly pick out our sample that represents California well, right? Because we make sure that we cover counties, zip codes, blocks, and people. And as you can see, this way is usually applied to geographic area samples. Okay, and let me say one thing about this cluster sample. One last thing about cluster sample here. Note, in this case, we know the probability of each person being selected, right? So we know the probability of each person being selected, so we're able to make adjustments. So using this method, we should be able to make adjustments to underrepresented areas. Okay, so we can put weight to select those underrepresented areas. So let me write this out. I can make adjustments for underrepresented areas or regions. Okay, cool. Right, so I think in this concept here is that knowing the probability of each single person being selected is important, right? Because we're still under the big probability sampling. So with this method, we can easily make adjustments to those underrepresented. Okay. Yeah. So in this video, we talked about probability sampling, and in the next video, we'll start talking about non-probability sampling. Thank you for watching. I'll see you in the next video.